In this section, we'll focus entirely on Bash. That's the born-again shell. We'll be focusing primarily on the various components that constitute Bash. You'll learn how to script different solutions using Bash. But we begin by exploring the interface, Bash itself, what it means to operate within a shell environment within a Linux environment. Now, as you can see, we're logged into a desktop, but the real power of any Linux system is the ability to gain access to a shell, and the shell allows us to automate the environment and to access more information much quicker. The easy way to do so if you're running a desktop environment such as GNOME, as we are here, is to right button anywhere on the screen, click on New Terminal with the left button. This will launch a shell which is approximately the full size of the current window, which is 640 by 480. Once you've executed the shell, you'll see what we see here, which is, or similar depending on the distribution that you're running, you'll see a prompt. No different than in a Windows environment or older Unix and mainframe environments, a prompt is a welcome input field or a welcome input screen welcoming the user of the system to enter commands for the shell to interpret, to render over to the system. So essentially what's happening here is as follows. We have an interactive environment that we can use to access the system. And the interactive environment is governed by the shell. In this case, that shell is called Bash. Bash stands for the born-again shell. It is the latest incarnation of the Bourne shell, the original classic Bourne shell for Unix. It also incorporates many of the functions you'll find, functions and features you'll find in other shells, such as the Corn shell, TCH shell, etc., and even the C shell. So we'll be using Bash. We have a prompt, and the default prompt in a Red Hat environment is as follows. The username at the name of the system space the current directory. We'll be showing you how to alter the prompt, but just so that you get a sense for what you're looking at here, the entire prompt consists of the prefix that I'm currently highlighting and then the pound sign. After the pound sign, we have a blinking cursor that allows us to input information. Now, when you see a pound sign within the Bash environment, that indicates that you are logged into the system as root. So I'm currently logged into the system as the root level user. If we were logged in as a different user, then that interface or that pound sign would be changed to a $sign. And we can show you that by SUing into the system as a different user. You'd need to know a different user on the system, of course, for that to work. So for example, we could do an SU, log in as the user Dean, who has an account on the system. In this case, Dean doesn't have an account, but if Dean did have an account, we'd be able to go over. Let's SU into the system as the user Linux CBT. And this lets us in, as you can see here, Bash recognizes that our user ID level is not root. And the user ID level is not determined by the name root, but by the user ID of 0. On all Unix systems and Linux systems, the user root is assigned the user ID 0. The shell, Bash in this case, makes the determination of what prompt to present, amongst other things, of course, depending on the user ID of the logged in user. We've SU'd in as the user ID Dean, and we've been returned a prompt of $sign. So one quick way to use Bash to determine whether or not a root level user has logged in or is logged into a system, if you can visibly see the system, is to look at the prompt. You can look at the full prompt, but the prompt is alterable. But one portion of the Bash prompt that's not easily alterable is the reflection of the last character here, which is $sign if the user is not root, and pound sign if the user is root, in the case up here. That's one quick indicator brought to you by the Bash environment. Now, what does it mean to have a shell environment? A shell environment interprets commands inputted by the user or by scripts. Now, since this is the scripting edition of the product, we'll be focusing our energies primarily on scripting. But before you can understand shell scripting using Bash, you should understand how the commands actually run manually in an interactive environment. So there are two things you need to understand: interactive and non-interactive shell interfaces. An interactive shell interface is similar to what you see here. We have access to the shell, and we can type anything we want, for good or for bad, on the command line. This is interactive, and providing that we press enter or return, the shell will attempt to execute the particular command. It's interactive. A non-interactive shell is in the case where, for example, we run a script. We've put all of the commands that we'd like to run into a shell script, a bash shell script, even if it were only one command, and then that command actually executes in the background by bash. So bash actually runs the shell script for us. That's a non-interactive interface into your shell environment. So we've SU'd in as the user Dean. We're still in the root directory. This tells us the directory that we're logged into. If we simply did a cd with no arguments, this would return us to our home directory of Linux CBT. That's another function of the shell. The shell performs command line parsing, which we'll be talking about in subsequent sections. Amongst them is the interpretation of arguments that are passed into commands such as cd. cd with no command. Cd is an internal command, by the way, for change directory. Cd changes directory if you specify no arguments to the user's home directory. Now we're currently logged in as the user Linux CBT, so we're now in Linux CBT's home directory. And again, the prompt reflects user at host and the current directory. And once again, if we were to do exit, we'd return to the user root home directory, and the prompt has changed to pound. So those are some real basics about the bash shell environment whenever you open the shell. Now this also applies to a console-based access or access from the console on one of the other terminals. Any terminal that you use to access the system. If bash is your shell provider, it will resemble the following, or what we're looking at. So whether or not you open the shell from a terminal, a GNOME terminal within a graphical environment, or from a console, or from a serial port, or if you've dialed in using a modem, you'll be presented with a similar environment. Bash handles the rendering of the prompt and the environment for us, and it is the default shell for the Linux environment. So we have a prompt, nothing major, but it's some basics for you to understand. $, $, the way the prompt is actually constructed, and by the way, this prompt is controlled by a variable called PS1. We'll be talking about variables, of course, since the art of scripting or programming in general requires the understanding of variables. Now I want to show you some of the default system files that bash relies upon for customizing the user's environment. This helps your understanding of scripting in that you need to understand how scripts will perform under different user environments. Because ideally, for security reasons, you should not aim to run all of your scripts as the root user. So when you design scripts, you should design them with security in mind, keeping in mind that the lower privileges you use, or the less you use the root level privilege, the better in terms of security. So let's look at some of the configuration files, because that'll help you to understand the environment that we're working with as provided by bash. Now bash has configuration files at two levels. You'll find configuration files for the system in general, so global configuration files, and you'll find user level configuration files. Let's cd into the etc directory. Cd is another built-in command. Now, there are two different types of commands. There are built-in commands, and there are actually commands that have files, whether they're scripts or binaries. So you have built-ins and non-built-ins. Cd is a built-in command. Let's cd into the etc directory. We're now in etc, and within the etc directory there's a file called profile. We can lsl profile. This is one of the main configuration files for the bash environment. This is a system-wide configuration file. It's a global configuration file. It contains various settings such as history size for the users that are logged in, and other settings that are inherited. You can use a pager command such as pager, or less, for example, which is your default pager, to view the contents of the profile file. And you'll see that it contains system-wide environment and startup programs for login setup. And it also mentions below, if you want to place system-wide functions and aliases, place them in etc bash rc, which we'll be looking at shortly. So the etc profile file is the main configuration file for bash. It contains settings like things to do with the path. Here's some more path manipulation. Here's some testing, some conditional testing based on whether or not the user ID is equivalent to 0. And as you know by now, the user ID 0 is equivalent to root. So if you are logged in as root, these things here happen as per this condition. And there's some other settings, some path munging, unsetting of path munge, which happens to be a variable, and other things. Ulimit. There are different variables that are set. The host name is ascertained using the hostname command, which is located in bin. As you can see, these backticks are used here to execute a command, which we'll be showing you how to execute commands using backticks from within your script to make your environment more powerful. Here's a default history size, as I mentioned before, as controlled or as determined or specified by the etc profile file. So within the etc profile file, there's a global setting for history size. This is important because as you use your shell environment, the hist size variable, as you see set here, and by the way, this is the way you set variables. You simply define a name. Case is not of concern, so it's case insensitive, but the common convention is to define critical variables with uppercase. So there's a variable here called hist size. Bash honors this variable, and what it does is it creates or maintains a history that is equivalent to the length of this variable. So for example, hist size is currently equivalent to 1,000. This means that for each user who uses the system, unless otherwise changed by a scope level or local level configuration file, which we'll be talking about, we'll have a history file which can contain at most 1,000 commands. Not 1,000 characters or 1,000 words, but 1,000 commands. So we can type in different commands such as ls, dir, pwd, cd, you name it, grep, ps, and those commands get appended to the history file, which we'll show you, up to 1,000 commands. This can be altered on a global basis and will be inherited by users. Of course, if the users have local files, the local files will override. Excellent. And there's some other logic, conditional logic here. But basically, you have some global settings such as the host name, the history size, the log name, which is equivalent to the user logged in, the mail directory, the user picks up the user ID, etc. These are global settings that need to be available across the board for all users of the system. And Bash reads those settings from the file etc, which is located in /etc, and it's called profile. That's the main Bash configuration file, which contains system-wide environmental variables. And it has some logic as well. There's also the bash rc, and we'll tab it out, the bash rc file, which contains aliases and functions. We can less bash rc to show you that. And in here is where you should put functions as well as aliases. So any sort of logic that you'd like to perform on a user who's logged into the system should go in the bash rc, whereas the etc profile file should contain global variables such as mail, log name, host name, etc. Any logic, any aliases, functions, logic, aliases should go in the bash rc file. Aliases, which we'll show you in a separate video, allows the user to essentially correspond a certain name with a command and arguments. So for example, if you want to run the ls command when you're logged in a specific way with specific arguments, you could set up an alias which would say ls is equivalent to ls-l. So every time when you log into the system you type ls, the shell actually really runs ls-l. That's what an alias is. And functions allow us to define for the shell to determine blocks of code that apply to different users, different groups, different system settings, etc. So this is the bash rc file. We'll be looking at it more and more. Here's a definition of the ps1 variable that I mentioned before. ps1 gets defined, and this controls your prompt. The ps1 variable accepts various attributes such as u for user, @h for hostname, etc. And if you're not logged in as the user root, you get a $ prompt. So that's the bash rc file. That's another main configuration file. So far we have etc profile, etc bash rc. These are two critical files you need to know about that controls your bash environment. So as you design scripts, if they break or if there are problems or if there are things for you to consider if you want to make your scripts portable, these are files that you need to keep into consideration or factor into your scripting design. So we have etc profile, etc bash rc. There's also a directory called etc skel. We'll go into the skel directory. This directory is quite simple. By default on the surface, if you run ls without any arguments and you have no aliases defined, you'll see nothing. So you'll think the directory is blank. However, rerun ls with the al option to show everything, and you'll see that the files that are here are all hidden files. These hidden files are important. Don't pay too much attention to the Emacs and GTKRC files. These files more pertain to the Emacs editor and the GNOME environment within the graphical environment. We're more concerned with the files you see here: bash logout, bash profile, and bash rc. Bash logout should be pretty self-explanatory. When you log out of the system, anything specified in bash logout will happen. Bash profile, you notice these file names are prefixed with dots. Now within a Linux environment, Unix environment, file names that are prefixed or begin with dots or periods are hidden files. So these are hidden files. Bash profile contains settings that applies to a particular user. So if you want to override or append to some of the items that are in the global, the system-wide profile file, specify them in the .bash underscore profile. Now if you make changes to the files that are in etc skel, subsequent users that are created on the system will inherit these new files, not existing users. So in other words, if you make changes in etc skel, only new users that you create will actually inherit these settings. In order to affect the users who currently exist on your system, you need to modify their individual .bash underscore files, such as, or .bash files, such as profile, logout, and bash rc. So it's good to set up the majority of what you want initially on a system before adding users to the system. Although there are certainly ways to make changes globally. In fact, you could simply write a script to make changes. So we have .bash rc, we have .bash underscore profile, and we have .bash underscore logout. And .bash rc, once again, houses personal functions and aliases that need to be set, again, on a user level basis. .bash underscore profile affects the user, but typically contains variables and environmental settings. And we can list the contents of these as well to show you. And we'll create a user to show you that these files actually get copied over. So here are some files. If the default .bash underscore profile file has logic which says if a file exists called .bash rc in the user's home directory represented by tilde, that's another thing we'll talk about, how the bash shell interprets tilde as the user's home directory. So whenever you see tilde and you're using bash, equate it to the user's home directory. If this exists, then source it. Then use the contents of that file. Otherwise, the only few items that are being set in the .bash underscore profile file includes the path, which it inherits from the etc profile file, and the home directory, which, of course, the home directory, the home variable exists, so the bin directory, if exists, is appended to the path. And then the path variable is exported, and username, if set, is unset. That's the only thing happening. Not much is happening in the local .bash underscore profile file, which the user will make use of on a per user basis. Let's list the contents of .bash rc. And as you can see, by byte count, it's actually smaller than .bash underscore profile. It contains basic settings, if exists, essentially run the contents of the file. Nothing major is going on here yet, but we'll be making changes to show you. But you need to understand the order of operation. The order of operation is as follows. When you log into a system, bash reads etc profile. It also reads etc bash rc. And these are global system-wide files. If exists, which is default, which is the case, by default, because etc skel contains these files here that you see, if exists on a per user basis, the following files are honored. .bash, and I'll put the tilde to indicate the user's home directory. .bash underscore profile is read, and tilde .bash RC. This is when the user logs in. So system-wide files and scope level, user level scope files are read and honored. Anything that's found in them, the bash interpreter will process and customize the environment for that particular user. So if you want to make changes that affects all users on your system, modify etc profile and or etc bash rc, depending on what you're modifying, of course. Functions and aliases, place them in etc bash rc. System-wide settings such as path variables and other variables, place them in etc profile. Those will affect system-wide users, even users who are currently logged in or who currently have accounts on the system. So if you have a system with, let's say, 1,000 users currently up and running, and you need to make a path change, make it to etc profile. If you need to make a function or an alias change, such as you'd like the remove command to run in a specific way, or the ls command or du command or df command to run a specific way, make them to etc bash rc, and that'll affect everyone. If you'd like to affect all users created on the system going forward, subsequently created users, if you'd like to affect their environments, modify the appropriate files within /etc/skel, because as I'll show you shortly, when you create a new user, the files from /etc/skel are copied to the user's home directory, including the Emacs and GTKRC, but because we're working with bash, we're concerned primarily with these three files: bash logout, bash profile, bash rc. Those files get copied over. And we can less the contents of bash underscore logout. Remember, these are hidden files. I'm just omitting purposely the dot, the prefix dot. Bash logout does nothing much but clear. Now, within a script file, or any file that's sourced and read by the bash interpreter, a pound sign or a hash mark, as you see here, as I have highlighted here, is considered a comment. So this is a comment. It's ignored. It's run from the user's home directory as indicated by tilde, and it's bash logout. All it does is clear. Now, anything you see within a script, for the most part, you can run from a command line. So if you ran clear, as we saw in bash underscore logout, all it does is clear the screen. So upon logout of the system, the screen gets cleared. That's all that happens there. So we're in etc skel, and I've just shown you pwd, which is another built-in command. And you have an idea now of how the environment works. The bash interpreter, let's show you where that is. We'll do a which bash. We've neglected to show you where that is. Bash is located within /bin, and it's called bash. And if you'd like to see the size of it, lsl bin bash, you'll see the size. And on a Red Hat system, it's installed as a package, of course. You can do an rpm query all, grep bash. If you're running a Debian system, you can do a dpackage -l and grep for bash. It'll show you whether or not it's installed. It isn't too big. It's 626K. We can rpm query all, grep for bash to see what comes back. And we'll be looking at quite a few other things we can do at the bash environment. We're running bash 2.05b 20.1. This is not the latest version, but it is the version which ships with Red Hat 9, which is the most popular distribution. So anything that's included in the newer versions, the newer minor revisions, that is, are minimal. But once you understand how this version works, you can update yourself on some of the slight differences. But the major release of bash is certainly version 2, with the minor release being 0.5. And you can also feel free to update your version of bash by acquiring the proper package. That'll get you up to the latest edition. But for the most part, you'll find that anything under the major release of 2 is sufficient. So we have system-wide files in etc profile, etc bash rc. We also have default files, which are located in etc skel, which are copied over when you create new users. And we also have user-level files within the user's directory, which are copied anyway when you create that new user. Now, if we were to add a new user, let's create a user called test. It seems as if nothing much has happened, but if we now change directory into home test, because the default home directory on a Red Hat system is /home, and we do an lsal, or LA, order is unimportant, you'll see the date, August 23rd, and the time, bash logout, bash profile, bash rc, in addition to Emacs and GTKRC, were copied from etc skel. And you can look at the differences. The file sizes will be identical. So by virtue of just creating the user, without even specifying a password or doing anything else, the contents of etc skel are copied over to the user's home directory. So for further customization for that particular user test, navigate into /home/test and make changes to the appropriate file, whether it's the logout file for execution upon logout, the profile file for system-wide settings such as path or variable definition, or bashrc for functions and aliases. If you need to do any logic, you can define functions and put some conditions in to check for certain things, or if you want to just set up aliases, you can, and we'll be showing you that, of course. So far, that's a primer and intro into the bash environment. It's set up as a package on a Red Hat system. We're currently running version 2.05, and it's a package. It contains global and local user configuration files. It's the main interpreter on the system. There's one other thing we should show you. Let's grep test from etc password. When you create a new user on a Red Hat system, here's the test user. Here's the user ID, group ID, and here you see the default home directory of home test. But more importantly, since we're concerned about bash, the last field houses the location of the interpreter of choice, the shell interpreter of choice for this particular user. On a Red Hat system and in Linux in general, bash is the default interpreter. And it's specified in etc password so that whenever the user authenticates to the system and logs in successfully, bash is instantiated. So an instance of bash is created, which we can find with ps or other commands. Bash is launched as a parent process, and it manages all of the child processes for that particular user. So you understand where bash is. You know what directory it's in. You know how the user logs when they log in, what happens. The system-wide files are executed. The local files are executed. You know what happens if you create a new user on the system. It's quite simple. We'll move on to showing you other things in regards to bash so that you're comfortable. We'll be looking at some of the built-in commands, how they work. And after we look at the built-in commands, we'll look at some more sophisticated things regarding to the shell, such as brace expansion, tilde expansion, the various expansions. In other words, the way the shell actually performs its interpretation. Once we have all of the basics, the hardcore basics out of the way, we'll actually move on to the science behind bash scripting. And once we have the basics of bash scripting down pat, we'll then proceed to creating useful scripts. What we'll do now is show you some of the concepts actually applied based on what we discussed earlier. So earlier we said that there are global configuration files including etc profile as well as etc bashrc. When I say etc, I mean /etc or root etc profile as well as bashrc. And those are system-wide global configuration files that affect every user on the system. There are also local files per user, or user scope level files that are stored within the user's home directory, represented by tilde, that can override the settings that are in the global configuration files or simply append to the settings that are in the global configuration files. So as an administrator of the system, you need to determine where you want the changes to take place. Should it be on a global basis or on a user scope level, or even a group scope level? But for the most part, you're dealing with user or system-wide changes that need to be made. Or should the changes apply to only new users? We're going to look at all three situations: global, local, as well as subsequent users added to the system. What we'll do is as follows. We'll set a new variable which doesn't exist on a global basis called linuxcbt. And that particular variable will be set, and then we'll log in to show you it in action. So the first thing we need to do is ensure that we're logged in as root to be able to modify the /etc/profile file. If you lsl /etc/profile, and the L option, by the way, when passed into the ls command, simply shows you the directory in long format as you see here. If we lsl etc profile, As you can see, only the root user can make changes to this particular file. Read write for root, that's the user. Read for the group root, and read for everyone else. So you need to be root to make changes to this file, otherwise the Linux file system will return an error. That's Pico. Pico is an editor which is typically available on Red Hat Linux systems. If you are operating within Debian or some other distribution, consider using Nano, Joe, Emacs, or even VI. Well, Pico etc profile, and this will open the file for us. And as you can see, we have a variable here called linuxcbt scripting is equivalent to scripting. Let's remove it, clean it up. Doesn't exist. We'll save the file. So the variable is not there. And if we were to echo, for example, the variable that you just saw for the current user, linuxcbt, you'll see it doesn't exist. Echo will echo a command back to standard out, which is the screen. We'll be talking about redirection shortly. Echo will print the command, and in this case, or it will print whatever you tell it to print, in this case a variable prefixed by the $. Now the $, is the delimiter for variables within the bash environment. So when you prefix a string with $, you're indicating or you're referencing a variable. So we've told the shell to echo a variable called linuxcbt, which is not set because we have not sourced the login files. We haven't relogged into the system. Let's modify that profile file again, and we'll enter the variable. And we'll navigate to an empty space. Here are some other variables such as user, log name, mail. Now, whenever you set up a new variable, in order for the variable to be available within the bash environment, it needs to be exported. So by simply setting the variable here is not enough. There's a set for user, log name, and mail, but that's not enough. They need to be exported, as well as for host name and his size. If you look towards the bottom, you'll see that the variables that are set within the system-wide /etc/profile file are exported. So we'll just set it right about here. We'll call this particular variable linuxcbt. And again, it's not case sensitive, it's just common nomenclature or conventional to specify variables using uppercase. We'll call this variable linuxcbt and we'll set a value. It's a string. With bash, there are no defined types. So setting a numeric versus an alpha is the same thing to bash, although bash is able to, when called, make decisions such as calculatory decisions. In other words, calculations. So we'll set linuxcbt equivalent to the string scripting, since this is the scripting edition. So we have a variable linuxcbt, it's equivalent to scripting, but we haven't exported it. We'll show you what we mean. Let's exit, and we'll log in using a new shell window as the user test, which we've created. But let's set a password for test. We'll set a basic password of ABC123. It'll say it's a bad password, but it'll set it anyway. We'll do a Control-Shift-T. That gives us a new tab. Within the GNOME desktop environment, we can operate within multiple tabs. If your resolution is higher, you can continue to open tabs as I'm doing here, and you'll have many screens. To close the tab, simply type exit, or Control-Shift-W should help. Now in this separate window, we're going to SSH into the localhost. SSHing or telnetting into the localhost gives us a full environment. SU will work also, but sometimes SU returns bugs or surfaces problems in regards to setting variables. So switching user doesn't always help. So it's good if you can get a complete clean shell by using a tool such as SSH or Telnet. We'll SSH into the local host, but if we don't specify a username, SSH will send the root user over. So we'll log in as the user test because we want to experience the bash environment under the auspices of test. We'll specify a password of ABC123, and now we're logged into the system as the user test. If we type who am I, it says I'm test. As you can see, the prompt is a $. We're logged into the system as test. Now if we're to echo the variable Linux CBT, as you can see here, the variable is actually set to a value of scripting, a string of scripting. Now you may be wondering, how come the variable is set if we have yet to export the variable? It's simply a function of the bash shell, but it's good practice once again, and we'll show you. Let's just make the changes to etc profile. It's good practice to export the variables that you've created. So here we have a variable Linux CBT is equivalent to scripting, but we haven't exported it. Let's simply put it in the list here. It's good programmatic practice for subsequent readers of your code to export the variable. But the login process exports variables in this version of bash that are found, that are set. Linux CBT happens to be one of them. So we've logged into the system as a user test, and we have this variable now. There are a few ways you can access the variables that are set on your system, such as typing set. If you type set, you can go hunting for your variable, or you can use set and pipe it to grep and look for your variable. Here it is, set Linux CBT. We'll show you that again. We'll type set, and we'll grep Linux CBT or any unique portion of the string. And there's the variable. You can also do a print environment. This will print various variables that are available on your system. And as you can see, Linux CBT is set after typing print environment. Great. So those are a few ways you can get to your variables. You can type set, you can type print environment. Either or should work for you. You should see what's available on the system. Or you could just simply explicitly echo the name of the variable if you know it, and the shell will do so for you nicely. So we have this variable. It's set on a global basis. What this means is as follows. Any user we log on to the system as, we source a new connection as, whether locally or remotely, will inherit this new variable. Let's show you that again with a different user. We'll log into the system as Linux CBT. So let's simply do a Control-Shift-T to get a new tab. And when we do Control-Shift-T, we're always, within a GNOME desktop environment, we're always given a new tab with the parent user's login. So currently we're logged in as root, as indicated by the root user prefix at the host. Let's SSH in as the user Linux CBT. The L option specifies the username, and we're logging into the local host. We'll need to specify Linux CBT's password, and once we've done so, we've logged in. Now let's do a print env, or print environment, and grep that particular variable that we've set to show you that it's actually available globally. And there we have the variable. So I've echoed it, and it's actually available. Print environment didn't return it. We can do a set, and we should see that it's actually set. And here's the variable, Linux CBT equals scripting. The log name, or the username who we're logged in as, is Linux CBT. Different user. We type who am I from here, Linux CBT. In this particular window, we're logged in as user test, but both have access to the Linux CBT variable. So we have three users logged in, a root user, a test user, and a Linux CBT user, and you can see the users are all prefixed at the same host. Excellent. Now what if we wanted to set the same variable on a user scope basis? How do we go about doing so? Well, the scope that's closest to the user overrides. So if we set the same variable, Linux CBT, is equivalent to a different value at a lower scope, such as a user scope, that setting will override. Let me show you what I mean. We'll exit this, we'll save changes. As the test user, we're logged into our home directory. Let's modify using Pico the bash profile file. Now there's very little set. However, let's set right beneath path Linux CBT the same variable name, and instead of scripting, we'll call this one edition. So in other words, for scripting edition. So the first variable set on a global basis is called scripting, or the value is called scripting. The value here is called edition. Let's export it. So now we've created the variable yet again. And in order for the changes to take effect for the test user, we need to either source the file or relog in. It's typically just easier to relog in and cleaner. Let's relog in as test to the local host. As you can see, we've reverted to root. We're back in as the test user. Let's echo the variable Linux CBT. As you can see, the variable is now set to addition. So that's what we mean by overriding the user scope file. If we ls al in this particular directory, you'll see that we modified the bash underscore profile file. It has a different modification timestamp than the other files. The other files were simply copied when we did user add. So now the value of Linux CBT is equivalent to addition. However, this user scope change has not affected the other users of the system. We can echo it for the Linux CBT user. It's still equivalent to scripting. Let's show you that in action again. In the third tab, we'll log in again to the system using SSH as the user Linux CBT. And we'll echo that particular variable, and you'll see it's still set to scripting. However, for the test user, because it's on a scope basis, the value is actually addition. It's that simple. And you can do a set grep Linux CBT. You'll see the value is set to addition for this particular user. If we're to copy the value over to, let's say, perhaps the Linux CBT user, it's set to scripting. So that's how you change it on a user level basis. Let's show you how to append a variable. It's quite simple. These are really the basics, but this impacts your scripting because it helps you to debug if necessary or when necessary. Since debugging is a fact of life, helps you to debug your programs or your scripts much quicker if you know what's happening where, when and where on your system. So we're logged in as test. Let's append a variable to this user test's bash profile file. We'll modify it. We'll find the pico that we executed, and we'll add yet another variable. This one will be called test var. We'll call this test var, and we'll give it a value of 1. And we'll also export it so that it's available. Now, if you notice the unset here, if you unset a variable, you essentially make it unavailable. The shell doesn't retain it for use. So now we have a new variable called test var. And this only applies to the test user. Let's log out and log back in to show you the new variable in action and to show you that it also doesn't impact the rest of the users on the system globally. Let's echo test var, and it's set to 1. Or you could do a set grep test. You also have print environment. You also have env for environment. Env will also show it to you. Environment grep test. There's the variable. And there's the Linux CBT variable. So you have set, print environment, and env for environment for returning your values. However, let's return to the Linux CBT user, log out, log back in. We'll specify the password, and we'll echo test var to see if it's set. We can do an env grep test var. You'll see it's non-existent. However, if we're to grep Linux, we don't have to type the entire thing. Linux CBT or any unique portion of the variable, you can see it's available. Linux CBT is equivalent to scripting. This is for the Linux CBT user. Run this command for the other user, test, and it comes back with the value of addition. Excellent. So you now know how to set variables on a system-wide basis as well as a user scope basis. The rest of the settings that are modifiable in bash rc, located in the user's home directory, or /etc/bash rc, apply similarly. So in other words, you can make global, functional, and alias changes, or you can make them on a scope basis. So if you want to append variables, you can do it on a user basis. If you want to make changes on a global basis, you make them in a /etc directory. The same applies for etc scale. Let's just show you that real quickly. If we navigate to etc scale, and you'll see we have the files here. If we're to modify, for example, bash underscore profile, and place a new variable. Let's call this guy test var, and we give it a value of 2, and we export it. Subsequently created users will inherit this setting. So let's export this particular variable as test var. So we have test var is equivalent to 2. We'll save changes. And now when you add a new user to the system, the variable gets copied over. That's the only time it makes a difference. So if we were to do a user add, and this is a whole new user, let's say test2, navigate to home test2, you'll see the newly copied over files from etc scale. And if we were to grep test var, grep is a parser, from bash underscore profile, we'll see that the variable exists. Test var is equivalent to 2, it gets exported. So if we were to log into the system as the user test2, test var is now set to the value of 2. So that does it for etc scale, the global and the user scope. We'll move on to showing you some more exciting things about the shell, especially the breakdown, the parsing of commands that are executed, and then we'll move on to some more of the basics before we perform scripting.